Hey there, Charger people. This is Mrs. Boyd. Thanks for joining me today, where we talk about isosceles and equilateral proofs. That just means that we're going to be involving isosceles and equilateral triangles. My cat just laid down directly on my work surface here, so we'll see how this goes. First, we have the isosceles triangle theorem. It says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. What that means is if we have a triangle and it looks like this, those two sides are the same, then we can say that the two angles opposite those sides are also the same. The converse of the isosceles triangle theorem says if two angles of a triangle are congruent, then the sides opposite those angles are also congruent. So this says if we've got a triangle and these two angles are equivalent, then we can say that the two opposite sides are also congruent. Let's practice a proof here. We're given triangle WXZ is isosceles, and segment XY bisects angle WXZ. That's our given. Well, first thing we're going to look at is this bisector part. If we know something is a bisector, we have to explicitly describe what is being bisected. We also need to say what an isosceles triangle tells us about our triangles here. First, let's say that segment WX is going to be congruent to segment ZX, like that, because that's the isosceles triangle theorem. Then we can say that angle WXY is congruent to angle ZXY, because that's the definition of an angle bisector. Lastly, we've got WXY is congruent to triangle ZXY. Let's write what we've got here. Got those two angles are congruent. We've got this side is congruent. Really, we should have to say there should be an extra step in here, and it should say segment XY is congruent to segment XY because of the reflexive property. But we can see when I've drawn it this way that we have, sorry, everything's breaking right this second. We've got side, angle, side. So side, angle, side congruence is what makes those triangles congruent. Let's try another one. We know that MO is parallel to NP. Well, let's draw our little arrows that show that. We know angle 1 is congruent to angle 2. Those are all given. So the two parallel lines here tell me that angle 1 is going to be congruent to angle 3, and angle 2 is going to be congruent to angle 4, because those are corresponding angles. So that's the corresponding angle postulate. Let's mark those on here. All 4 of those angles are going to be the same. Now, we can also say that angle 3 is congruent to angle 4 because of the transitive property. We know that angle 1 is congruent to angle 3, angle 2 is congruent to angle 4, and angle 1 is congruent to angle 2, so that means angle 3 has to be congruent to angle 4. Now we can prove segment LN is congruent to segment LP because it's the converse of the isosceles triangle theorem. All right, we're just using these new things that we sort of already knew about isosceles triangles to make our proofs a little more robust. Flip your paper over and let's talk here about what we need to know. Equilateral triangle corollaries. A corollary is a fun word to say. First of all, let's go ahead and be honest, it's fun. But it's also a statement that we can use in proof. So a triangle is equilateral if and only if, while we're here, we abbreviate that with IFF, if and only if. It is equiangular. So if all the angles are equivalent, all the sides are equivalent. Each angle of an equilateral triangle measures 60 degrees. That's because 180 divided by 3 is 60. So we can use those corollaries. Oh, these are all filled out for you. That's fun. Well, let's pretend you can't see these things, shall we? We know JKL is equilateral and JKM is congruent to LKM. Those things are given. So we can say JK is congruent to KL because in an equilateral triangle, all sides are congruent. That's our corollary we were given. And then we can say KM is congruent to KM because we love the reflexive property. Now, we can say, since we could say that JKM is congruent to LKM, we have, everything is missing. We have a side angle side congruence. But we want to prove that angle JMK is congruent to angle LMK. Well, that's because congruent parts of congruent triangles are congruent. Let's keep this party started and going. Keep it on. Holy cow. We're given triangle JKL is equilateral. And segment MN, is parallel to segment JK. Well, we know that angle J, angle K, and angle L are all 60 degrees because in equilateral triangle, all angles are 60 degrees. So we can say that guy there. We can also say that angle LMN is congruent to angle LJK. And angle LNM is congruent to angle LKJ because they are corresponding angles. Well, we can say the measure of angle LMN is equal to LNM, and that's equal to 60 for substitution. If these 3 angles are 60, then these are also 60. So that tells us that triangle LMN is also equilateral because all angles equal 60 in an equilateral triangle. I hope these make sense. I hope you can refer back to these easily to complete some fantastic proofs. Let me know if you need any help, and I'll see you soon.